words about the session here today. So yeah, I gotta go to the next. Now I have the feedback, so I will mute. I will also mute participants who create feedback. So I will do that as a host. So just this being said, welcome again. This is a webinar series of the Utopia Train project for all the Utopia partner universities, all 10 of them. All the documents that we make available in the sessions like this. The training documents for research data management that will be mentioned, and also the recordings will be made available on YouTube and Zenodo respectively. We have a couple of other training resources already on there, for example, on Open Science and Horizon Europe, on citizen science. There are many other resources as well, which we make available throughout the project to researchers and other colleagues at the universities of Utopia. Also, to show this in the beginning rather than at the end when nobody, when the, like say, attention is a little bit lower. This is the first webinar out of 2 in this case on research data management, and on Thursday we will also have another webinar that looks a bit in more detail into the FAIR principles for research data and the role of metadata in this whole thing. So we'll, for those that will be joining both of these sessions today you will get a very thorough introduction already and a very good overview, but on Thursday it will be even more advanced on some of these topics. So I hope many of you can register to this one as well. And as a heads up as well, in December, as part of the Ethics Week of the VUB, where I'm working, and which is a partner in Utopia, we're having a session on reproducible and replicable research, which is also very much related to the open science work that we do in Utopia Train. It's actually co-organized kind of by the Utopia Train project with also different speakers from several Utopia universities. And this is also open for Utopia participants to register and to participate. And so you're most welcome to attend the next 2 trainings. And of course, any future activities that we might announce. Today, the topic is, as I said, the basics of research data management. And we have 2 presenters here for that topic until around 5 p.m. Central European time these days. The first one is Sebastian. I will just make a very short introduction of the 2, of you first in this case, who will talk very much about the basics of research data management, some basic concepts, the reasons behind it. And to, for example, look into data management plans as well. That's a topic that you will cover. And second, we have Julie, a colleague here from the VUB as well, who will introduce mainly criteria for data repositories and how to find and identify data repositories that are more suitable or the most suitable for the research data that you might be producing in the throughout your projects. And this was kind of the start for Sebastian. I think just to say a few more words, I will stop sharing here if I find the right button. Sebastian, you're here. Welcome very much. You are, if I am not mistaken, you're assistant professor at the University of Ljubljana with a background in physics. You're also active in the Eurodoc, so very much concerned with the interests and issues that young researchers and early career researchers face. So also very interested in open science, I think, in this context. So stage or screen is yours to take over the presentation.
Perfect. Thank you so much for the kind introduction. I'm gonna share my screen and you should be able to see my presentation, I hope.
Yeah, it works.
So yeah, I'm very happy to have this opportunity and talk a little bit about basics of research data management and some of the basic context and what's behind all of this. As you said in the introduction already, the presentation already is available on Zenodo in the Utopia community. So you'll find the link and also the small QR code. So if you want to follow up with any of the links or resources, this should be relatively easy then. And yeah, without further ado, let's dive into it. So research data management, why should we even care and why should we be concerned now with like 1.5 hours of webinar just on this basic practice, let's say. Well, it's for us as researchers, it's of course part of our professional tool set. So in the same way, like you see different kinds of professional tool sets presented here in the images, data management, handling data, and knowing how to properly do all these things. This is, of course, something that for us as researchers is a part of our daily life and something that we should be well familiar with. So if we start then for the very beginning, what is data after all? Well, to put it very simply and very shortly, data generally is information. Maybe a little bit more detailed definition to start on is from Van Berchem and Grothveld. So all tangible forms of material, like data, may take forms like facts, observations, interviews, recordings, measurements, experiments, simulations, software, and so forth. You can read the more details yourself. And these can have all sorts of different forms and formats, if you're talking about digital data on the computer. And a lot of these kind of forms and a huge overview of tables, how this can look like in the different fields, is, for example, presented in this book by Sanchez, Data Mindfulness. So if you want to look into more details, what in your field might be interesting and what you might be concerned with and not be aware of, that's certainly a good resource to follow up on. And particularly then one form of data that's also very important as a researcher, of course, is metadata. So what is metadata as opposed to data in general? Well, we have some very intuitive examples, I would say, that we can see on the screen. I think you can read and see for yourself. Metadata is really the description of the data, and it's like the map leading to the treasure that you can see, or like the description on the beer bottle suiting to the location as I'm currently presenting out of Prague. All these can be forms of metadata, so data describing the data. Details really on metadata, how to structure this, how to handle this, and so forth, as we already heard from Lennart in the introduction, will be given in 2 days, this Thursday. Without further ado, let's take a look into practices with the data. And of course, depending on different roles that you may take at your institution, these kind of practices may differ quite strongly. And so with these basics, the introduction that we're taking today, of course, we're taking a look more for the subject matter expert, for the researcher that is handling their own data. There's, of course, all sorts of different support services in place. So for many specific questions and many specific practices like fair data, for example, machine readable data, there's in many of our universities, there are data stewards in place that you can ask, librarians, and all sorts of other roles. But we're going to be focusing really on the basics. And if we start very basically, then you might say, well, what's all the fuss with the data management? After all, like for me as an experimental scientist, I go to the lab, I do my measurements, take my data with me, analyze it on the computer, and then I'll publish it. So what's all the fuss about it? Well, the thing is, even this very simplified, shortened view on data management, or on this kind of cycle that's behind this, already has a lot of steps and a lot of considerations that come into account. So, of course, when I'm doing my measurements, I take notes in my lab book. So I'm taking down certain forms of metadata. I make sure that I can take the measurements, all the data that I collect with me to analyze them. So I need to have a proper storage to do that. I need to have the proper formats that I can open on my computer to analyze it. Maybe some proprietary measurement formats will not do me well. And so there's a lot of individual factors that I'm already actually practicing, already taking into account, even though maybe in my everyday life at work, I'm not so much putting really lots of consideration into this, but rather perform all the tasks. And so in the next slides, we're going to look into a couple of these different points that you see on the slide, and be concerned a little bit with those details before we put everything together into the large picture. So the very first point, of course, is you need to have a secure storage for your data. Just putting something on a USB stick or on different forms of flash drives is not really good practice. There's different kinds and different ways of how to store data. Like you can see from writing it down, saving things as files on the computer. Now there's a lot of other forms how you can store or where you can record your data. If the cartoon showing Instagramming the measurement data, if that's the right practice, that's for you to decide. But yeah, there's a lot of different practice that you can really take into your daily routine. But of course, you should make sure that the data is stored in a proper way, that you can access it, that it's secure, and that you avoid data loss and avoid such a situation as you can see on the bottom right-hand side. And of course, there's a couple of things to take into account there. If I just have data on my one hard drive, the hard drive might may get faulty. There may happen something to this hard drive just because of it becoming old or because of some incident happening. So of course, it's better to have it stored on a more secure system, like these RAID systems where several hard drives are connected in a secure way, so that data is really stored across those, and a loss of one hard drive will not cause loss of data. Backups should be done, and particularly to really have a secure storage, the ideal way is to have the data stored in multiple locations. So even if, for example, there's a water damage or fire in the lab, both of which happened, by the way, in my former lab where I was working in Germany. So these are not outlandish things, but really such things happen. And so having the data stored in multiple locations physically already helps a lot to keep the data secure. And then, of course, backups also in the form of a different directness of accessibility. So a few years ago, we had an incident with the computer virus that corrupted all the data we had on our shared hard drive that we had in our shared cloud. And so thankfully, this had automatically backups taken onto magnet bands, so we could simply restore all the data and no loss, no harm was done. So having different forms of storage in different locations where I store my data, that's really essential to keep all the things that I'm working on secure, and not to by any accident or any incident happening to lose it. There's an interesting short video that I invited to watch later that's explaining this 3-to-1 rule, having at least 3 different copies, at least 2 different locations. And so you can take a look into detail more on this if you like later. But the last point that I want to highlight, of course, is whatever you put up for your storage system, however you handle your data, one thing that's very important, of course, is it needs to be easy. It needs to be easily accessible, intuitive. And so one thing that's really recommended, of course, is have a good degree of automation. So for example, if I'm taking a measurement at one of the microscopes saves the images automatically on its own hard drive and on the shared disk that's in a different location. So already I have at least 2 versions of the measured files. Already this catches a lot of possible incidents where I could potentially lose my data. So yeah, having things automated and very easy and intuitive, that's something to set up just once, and then have a really easy time and yeah, save a lot of efforts. The next thing, of course, is documentation. So documentation is of course, very important, so not to just record all the data and after a certain amount of time not to find your data anymore, not to know exactly the details that are maybe important for the things you want to do with the data, however you want to analyze it or use it further on. And so also with this, it's something that should be, of course, done in as much detail as possible, of course, so not to overlook something that might become important later on in the research process. Maybe if it's again about an experimental scientist, some parameters, some conditions in your lab that may change, that you're not paying much consideration to, but that might have an impact later. For me personally, for example, this is temperature and humidity is something that in rare occasions, but can have an impact. And so I'm usually simply recording this, if nothing else, at least to take a simple picture from the of the device. So I have the reading with a date and timestamp and a location, immediately put this on my cloud, and so I have this information available. So there's a lot of these small things where it can be very simple in the approach, but at least the important thing is for all things that you do, keep the entire documentation so that really the data, the metadata is linked together, that you find what you did, how the data was created, what's inside the data, and how to use it. And so rather being more explicit, rather also having things put down in several variations can help to really make things easy later on. Again, good documentation also includes having an easy file naming system. So to find the proper data and metadata and how they relate together, or having a intuitive directory structure that is set up for you and keep in the same way. So also after maybe several years, when you might want to revisit some of your older data, you still can find it, you still can access it and make sense of it. And yeah, it's really like the comic shows. Nobody is really taking time after some project is finished to then sit down and start documenting all the things, all the data sets that were created through an entire project. But really, documentation starts in the very beginning. And if I do it from the beginning, in a good way, then it saves time already then. But a lot of time and resources, particularly later on when I'm using and reusing the data. So documentation, that's something very important to consider. However you create your data, however you do your measurements or whatever work with data you're doing, find a proper documentation for that. Then, of course, with data formats, many of the things that, for example, we do in our line of work include proprietary formats that are related to the instruments that we're using, different microscopes, different spectrometers, and so forth. All of them come with their own proprietary data formats that you cannot access if you don't have the very costly software. So it's something very obvious there that it's really helpful to not just save the proprietary format, but to immediately also export the raw data into a data format that's going to be accessible in other software, and that's not going to require this proprietary one. Of course, in many cases, exporting data can lead to either loss of certain information. So if I'm speaking about those microscopes, for example, as one example, the original proprietary file includes all sorts of information, how the measurement was done. So this is something that if I'm just exporting the image, is obviously lost. So of course, when doing this, I need to be aware what kind of data am I exporting, what am I getting there, and what's a useful way to have it. But it's always a useful thing to set up the line of work such that you have different data formats, and particularly come from proprietary to free and open data formats. If we're speaking about images or huge data, then there's also different kinds of formats. Some are compressed, and always if I use compression, for example, I'm using JPEG images instead of TIFF images. This compression saves a lot of space on the hard drive, but of course also loses some information. So this is something to be conscious about, and to consider how to keep your initial raw data and how to further work then doing the analysis. And one last point on proprietary formats. So one particular thing that is often mentioned is then the use instead of Microsoft Excel to at least if you publish your data, to publish this in something that's an open format, not owned and licensed by a company like the Excel sheets are, like this data format is. So the common practice is to export into comma-separated values. Again, also there, of course, the downside is that if you did any analysis and any formula or any automation in Excel, this will then be lost in the comma-separated value format. So having both kind of formats in parallel can, again, help very much. But think about these formats and make things as easy available, because also for yourself, you may at some point upgrade your software. So at some point when you create it or process the data format may vary with the newer version, and the backward compatibility may be problematic. So even for yourself, it can be very helpful to have different data formats. The next point is, of course, versioning. So obviously, there should always be a difference done between the initial raw data that you're initially producing and then any analyzed data where you're doing changes or you work with the data. These usually should be in different data sets, so make really absolutely sure that any raw data that's initially created is not going to be corrupted or not going to be changed during your analysis process. But also, while you're handling data, it may be useful to keep different versions, to, for example, keep a backlog of changes. And of course, then keeping these kind of changes in a very nice and structured way. So also these will make sense later on after a while. So you really know what to do with these kind of versions and what happened there. This includes relatively simple advices such as avoid text such as final, because rarely do you ever know when a version is really the last final version, or if any changes still need to happen later on. And so usually common ways to do the versioning, of course, is using date or time tags, using semantic versioning, for example, with this 3-digit system that's particularly in the software world, very much used to have major, minor, and patch versions. So there's different ways how to tag this, but versioning can be something really helpful and something that you might consider while you're working and processing your data. The next point is, of course, you're not just storing and using the data. At some point, you might want to archive this because maybe your project is about to end, because maybe you have processed a huge chunk of data, you have published whatever you wanted to do with this. And so for the time being, you're done with your data, and you want to just clear the space in your Active Directory for the next data that's coming up. And so archiving is also an important point. Now, of course, we don't want to end up with such a swamp like we see on the right-hand side image. So whenever I'm archiving data, then, of course, I need to consider how do I do this so it's still later on going to be usable. Somebody is going to be able to find it, make sense of it, and is able to reuse it. And that's starting with myself, of course. So if I'm doing this in a nice way, in a proper way, that I can still easily go back some 5, 10, 15 years and still reuse those data that I produced then. But of course, this again keeps all these same kinds of consideration, how they're documented and how do I do this kind of archiving. But also then there's, of course, the consideration which data is really worth archiving, which is worth keeping, and which data maybe not may not be useful to anybody in the future, which is, of course, always hard to estimate. But so to really think what to preserve and to really curate this data that you do archive. Important for this also is, of course, what's your legal framework? So what kind of requirements apply to you? Maybe university has a policy in place for how long you're required to archive your data. Many funders do so, like many funders across the European Union require at least 10 years of storage of the created data, at least 10 years of archiving. Many repositories that we have access to guarantee for you that all the data that's uploaded there is going to be maintained and upheld at least 20 years. So these time periods are also worth considering. And this is then, of course, something that you would need to check back for your particular situation. And if you're archiving the data, then you might also consider maybe to making the data available not only to yourself or to your lab colleagues that are coming in the future, but maybe more generally to other scientists and other researchers. And so you might want to think about publishing your data and making this maybe openly available. And this is, of course, a huge topic for a good reason. So I believe all of you have heard already about a reproducibility crisis, that we really face the situation that much of the published research can hardly be reproduced because of all sorts of issues that can be found. And one step to overcome this kind of crisis, of course, is making all the data available. That's something that really, for me, represents the initial step into open science. Just with a short background story, when I was doing my doctorate, there was one particular series of measurements that took some not even 2 weeks to conduct the measurements. And after this, I was reviewing literature for more than 2 months to really put together the reference data that I crucially needed for my analysis. And I read literally several hundred papers, then came up with a mechanism to sort out the most credible sources and the most reliable and consistent ones to really use for generating my reference data, but I had tremendous troubles and thus had to spend a lot of time and efforts simply because none of those hundreds of papers published neither the entire protocol, how they did their analysis, nor did any of those publish the entire data set that came out of the analysis. And so by having neither of them, none of the publications were complete enough for me to use them for myself as a reference. And so reproducibility, making your actual data available, is something that can help a long way and in different ways that you might not yet imagine. And this, of course, also includes artificial intelligence approaches. It also includes mining of data. You don't need to be concerned with a typical big data. You don't need to be concerned with some geographical or astronomical data, for example, that come to mind. But many small studies also may be very well mined in the future for all sorts of different different studies, hypotheses, for questions that people want to work on. And so also your maybe very small data set may be very interesting for this, but should then, of course, be published in the proper way. And so, yeah, overall, it's a sort of accountability, and it's part of integrity of your research work that you're doing, in my opinion. So yeah, publishing data and making data openly available is something that not just many funders are starting to require now, but something that really has an enormous worth to it, and it's really yeah, highly recommended, of course. And then again, we're back at items of curation of the proper metadata to make these kind of reuses possible. Of course, we need then to be concerned, where do I publish my data? Where do I put my data to make it openly available? And this is something that we're going to hear about later on in our next talk by Julie, how to select the repository and what's all going into this. Of course, then there's further things that we'll need to look into more detail, such as licensing, persistent IDs to be able to access the data, and so on. But yeah, you can see that there's not just like a black and white, having data published or not, being open or not, but there's all sorts of facets, like in this 5-star model that you see in the image. And so, yeah, if I make the data openly available, then one important thing, of course, is I need to provide information about how other people can use or reuse the data. You can see on my presentation that I tagged it as CC BY, and so these Creative Commons licenses are yeah, have really become the de facto standard, have become what most people are using. There's other models, of course, that are available as well, but these are so intuitive and so well applicable to most of the situations for researchers that these are the ones that we most commonly see. And so these have a huge range, as you can see, from being public domains available to everyone, to something where you cannot change the data, not use it for commercial applications, or yeah, any of these. So that there's really a huge variety what you can allow or deny, how other people can use your data, and it's very easy to indicate this and really determine what can be done. Another point about intellectual property rights, of course, that's also something that's quite often coming up. Well, if I want to use this for any commercial applications, if I want to maybe file a patent for this, even as a researcher, there's lots of things that I can do in terms of exploitation, in terms of also securing the intellectual property rights. Well, then obviously, if I make it openly available, that's something that's going against each other, right? No, that's actually not really a controversy, but it's really just something where you need to be right in the timing. That's to say, if you want to reserve intellectual property rights also for these kind of commercial applications, then make sure to first go in this direction, to first apply for a patent or other forms of intellectual property rights before you make the information openly available. Otherwise, both of them can go in parallel, and there's absolutely no problem with that. Another important point then is, how do I really access this data? So I have published my data somewhere on the repository. Maybe it's also indexed somewhere so people can find and want to try to access my data. How are they going to do this most easily? How can they access the data? Well, the best thing that you can have is a persistent identifier, so an identifier that's guaranteed by ideally a standard or an organization keeping this up, and having the guarantee to be usable also after a longer amount of time, not like many web page addresses that might go corrupt after just a few years and don't work properly anymore. But good examples for persistent identifiers can be permalinks to websites. For publications and for research outputs, the most often used system is the DOI system, the digital object identifier system, which is even standardized and has the institution behind this to truly uphold this kind of identifier system. For identification of individuals, we have the ORCID, this ID system that really has now usages in all sorts of places and has been adapted by many people. For other, maybe even older and less digital information, for example, a persistent identifier also is on the back of most of your books. This ISBN number, this is also one identifier that's been upheld and where the information can be retrieved many, many years after to still read the right author's book title, publisher, and so forth. So it's something that we find in many of our aspects of daily life, not just at work as a researcher. Then, of course, publishing the data, one thing that's really highly recommendable is making the data fair. As we heard before, there's going to be an entire part of the webinar in 2 days, this Thursday, that's just covering fair data, how to make data fair. Just to have it mentioned here already, so fair data means it's data that's findable, so people can discover it, that's accessible, that's interoperable in different kinds of systems, and really reusable for all sorts of applications. And just to already overcome some misconceptions. So fair data doesn't necessarily mean open data. Your data can be fair, but not very open. And fair data is not exactly the same as machine readable data, but it's of course what it's aiming for. So that it's findable not just by humans, that it's accessible and reusable and interoperable, not just if a human does spend the time, if some researcher sits down and spends time to do that. But of course, if it's possible to be accessed by some algorithm or some software. And so usually if we talk about fair data, then of course we're looking for machine readable data, but it's not exactly the same. So yeah, more information on this in 2 days. So just to further promote also the next parts of the webinars. Another point that's, of course, very important to take track of, that's not applying maybe to all of us, but to many of us, is GDPR and other kinds of sensitive data. So, of course, always if I'm collecting, storing, processing any kind of data that contains personal information, biometric information, genetic information, health-related information, and so forth. So all these kind of things, of course, are sensitive data, where I need to take special care, where I need anything that's connected to an individual, I need to have explicit consent for the purpose that I want to collect and use the data for. I can only use it for those purposes where I have the written consent. For many things, it's of course then recommendable to anonymize or pseudonymize the data. There's all sorts of tools to do this, and this is a whole different aspect that we're not going to go into too much details. And there's also other things that apply regarding storage periods and particularly the safeguards, how to store the data. So this is such a huge topic and one that's also so legally relevant that for sure this is something, if this applies to you, you should always confer with your data protection officer at your institution to make sure all the practices you have in place are all right and are really keeping up with the requirements by law. Then, of course, if we take all these different things into account that we now took detailed look into, then this, of course, includes costs. So we have the data collection, the documentation, the storage, and the preservation when we archive and publish it. We have considerations about access and security and how this is available for reuse. So all these kind of different factors, of course, come with efforts that I spend to make this all happen. And also, on the other hand, also with infrastructure costs for the storage facilities, for whatever I'm gonna use there. And so all these kind of different costs, these are, of course, costs that are eligible usually in all of the funded projects. So this is also something that I should be aware of early enough to be able and plan those into my cost plan. and to be able to then get all these kind of costs reimbursed. And so with this, we're already sort of wrapping up a lot of those individual concepts and coming to a conclusion where we see, well, there's so many aspects that planning, of course, really does make sense. And as we can see, it's a little bit more complex than this very simplified approach that we started with. There's a lot of different ways how this research data lifecycle is depicted, different graphics that are available. This is one that I find most comprehensive and most usable for my own purposes. And so if you want to read more about the descriptions, this is one that has been created in Harvard, and there's quite a good blog article about this that you find linked below. And yeah, you will find pretty much all the different things that we were talking about now. You will find this in this research data lifecycle and see it's really something that's not just one linear thing and then it ends. But of course, after collecting, creating the data, analyzing this, evaluating, using it, then sharing and storing or archiving it, it can, of course, go into access, into reuse, either by myself for follow-up research projects or by somebody else who uses my data for some other purposes. And so then this all starts all over again. And of course, with those many different aspects, it's really very worthwhile to do the planning and the design, and particularly to do this in the very beginning, to really be sure about how am I going about, what's important to consider. And by setting up these processes once in an effective way, I can really already save a lot of time and a lot of efforts during my project, and be sure to really get the most out of the data that I create and that I then use. And this really leads into research, into the data management plans that more and more funders are also requesting from their researchers. Some of them just request that you upload this during the lifetime of the project. Others already even request this before you even apply for the project. So with the project application, you already need to have an initial version of a data management plan. Also, some of our institutions have put this in place for the doctoral programs. So all doctoral candidates, also relatively at the beginning of their doctoral training, need to produce a data management plan and need to be conscious about the practices, what they are going to do. Of course, this has different levels of complexity. And so if we see for these data management plans, this is really a helpful tool, but needs to be fit for, or needs to be really suited for the individual purpose where I want to plan my data management. And then it helps to set up the efficient practices, avoid any data loss or double work, and really allows us to estimate the efforts and costs, get this reimbursed, revise our own practices. And yeah, it's something very, very useful. It's a useful tool that helps us improve our own practices. That's the main point and the main idea, of course, with this. And in particular for larger projects, then it can also be very helpful, not just to have one sort of exercise in the very beginning to draft the data management plan, see how do we go about in this project, but also after a certain amount of time to revise and check, is the way how we started into the project still the most effective one? Do we have everything covered, or is there a need to change something, or can we improve our practices to be more efficient? So it can be very, very useful, particularly for huge practices, to also have several stages where data management plans are revised during the project duration, and yeah, thereby help to adapt to new circumstances. At least with every new project where certain aspects change, it can really help to adapt your own practices, to not start with a very good practice that's very well aligned with everything that you need for research. And over time, your research starts to change, the questions that you're dealing with start to change, and you find yourself at some point with the data management practices, with your research data management, not being really fit for the purpose anymore. And so with these kind of things, data management plans really very much help. And yeah, in essence, these data management plans, there's a lot of different tools that really help you very well guide you and help you through this kind of process. So as said, for the doctoral candidates, at least for our institutions, for the University of Ljubljana, we have this in place with materials. There's an introductory lecture series, and so the doctoral candidates are really led very well into this. For projects, there's different kinds of templates. Like, for example, for Horizon Europe project, I will need to adhere to the requirements by Horizon Europe, by the framework program. And these are available in, for example, different online tools. And a couple of them you see here on the screen. So there's, for example, the DMP online tool, which is based in the UK, which I find very easy, very intuitive. There's, for example, this Argos tool at OpenAir, which has the huge benefit of being integrated with the Horizon Europe system. So already by using these tools, this guides you through the process that's required of you anyway. And through the integration, it already links all your data systems, all these things with your project. So you have an easier time submitting all the project documentation that also you're required. So it's really easing your work in different ways and at different stages throughout the project. As said, there's a couple of other tools. These are just a couple of examples, but the recommendation always would be check out these tools, look at them, see which one does work best for you. And then use this one really to be effective, because it's a tool for you. It's not the meaning is not in itself by using it, but using it as a tool for its purpose. As said, different repositories are then, of course, worthwhile to consider. And again, this is something that we are gonna hear about in more detail in the next part. So just to have already some initial stage. There's ways to discover this, like the free data website, as database of repositories. There's different field-specific or general ones, and if nothing else, then there's always sort of a fallback option to go to Zenode is one of the largest ones that's accepting all kinds of research, and that's based at CERN, so at one of the largest infrastructures that we have in Europe. So that's really helpful. Also, think about repositories or different platforms and infrastructure more widely, more openly. Like, for example, GitHub was created as a tool for software developers, but can also be very helpful and is indeed used by several research labs to manage their data, and has the added benefit of not only being open sourced and having really interesting ways of collaboration with several researchers, but also being interested with some repositories. So you have a really easy and quick time to publish your data after all. So there's lots of tools that you can use. Without extending time too much, since I'm already nearing the given time scope and the given time frame, check out the different training resources. Here's just the 3 short recommendations that I found myself very helpful to get started with all sorts of these practices. And it's, in the very end, it's time well invested, because it helps you with your own practices become more efficient and get more value out of the work that you do. Electronic lab notebooks, particularly for experimental scientists, can be a tremendous help. Personally, myself, I'm a little bit struggling with this, because quite often I'm somewhere stuck between handling machines, handling some different chemicals, and then going to some tablet or to some computer to put all this information of very different, very flexibly designed experiments. Didn't really pay out for me. So this can be an option for you to really simplify your processes very, very much. There can be other options that are equally well suited, that are equally fine. So as in any of these cases, find a practice that really fulfills all these kind of conditions, that works well, but particularly works well for you and with your practices and with your research that you're doing. And so, in the very end, if you later on have different questions, then of course there's in all our institutions the support system in place. So some of our institutions, maybe not all, that's why there's the question mark indicated, because I'm not familiar with all the institutions, but many of our institutions already have data stewards in place that can really help you with very in-depth questions. Pretty much all our institutions need to have a data protection officer. So this is also then again a support structure, particularly for sensitive data, where you can ask all your questions. And if in very much doubt, usually ask your local librarian. They're so much knowledgeable and can help out so well. And this really goes a long way to simply, if something is unclear or you're not familiar with all things, ask the proper questions, and you will receive the help. And with this, I'll close my talk, and I'll be happy for questions myself, if there are any.
Yeah, thank you, Sebastian, for the very passionate, I think, introduction. I just posted in chat as well. Is there anybody from the audience who would like to pose a question to Sebastian? And say you can speak up. You can put them in the chat. You can also save them for even later if you still need to digest a little bit of the information, because it was certainly quite a lot. Maybe while the audience is thinking, I think also maybe to highlight one thing. Indeed, each Utopia university has some kind of support for these questions. I'm fairly sure that everyone has a data protection officer. I think that is required by European law. I think data stewards are not yet available at every university, all of the 10 at least. But there's certainly someone in the research office or the library, indeed, that can answer some questions that you may have, especially because in these webinars we cannot present all the institutional infrastructure that is available at all the 10 members. So you showed, for example, the DMP.be, which is the Belgian tool for data management plans, but there's also a French one, I think, for our colleagues at Cergy. And these kind of things. I think the audience is very shy, but that's okay. It's Tuesday afternoon after all.
If there's coming up any questions, even later on after the webinar, of course, you have my contact details, so you can also, of course, always post your questions to me or to your local colleagues. So yeah, and if you want to revisit this, as said, the presentation is also published. So yeah.
Thank you very much.
Some question being typed just now.
That's it's exciting. Well, it is a thank you. So I would second that for now, but maybe there will be questions later. We still have some 40 minutes, and I think Julie will take some of that time, even though Sebastian, you already presented you alluded to some of the context that Julie will present. So I welcome now Julie, a colleague here from the VUB, the Vrije Universiteit Brussel. She's working in the archive of the VUB as a data archivist, and she will especially look into one of the topics that Sebastian has mentioned in the end. That is about how to pick and identify a suitable repository for the data, especially for the storage and preservation of the data after, say, the active phase, I think. Yeah. So Julie, if you want to take over now.
Okay. Hello, everyone. I will try to share my screen first. Let's see. Is this clear for everybody?
Yes, we can see your screen, but you need to...
Yeah, of course,
full screen.
Yeah.
Perfect.
Okay. So I'm gonna try and give you some information on the selection of a trustworthy research data repository. This presentation is based on the training guide that will be published hopefully somewhere this month. The DOI is already reserved, so, well, you can look it up when it is finally published. Let's go. So firstly, I think we're gonna do some theory on what a data repository is exactly. Is a database infrastructure for management, storage, and the dissemination of research data. The database should be searchable, and the data in the database is discoverable through metadata. The repository should publish the data during or after the research project. Well, you should publish it in the data repository, and it provides a prolonged public access to the metadata or the data. And the data in the research repository should be as open as possible and as close as necessary. This means that not all data can be published in repository. You should watch out with, more sensitive information, for instance, personal data, but we'll talk about this later on in the presentation. There are a few types of data repositories. Firstly, we have a general purpose repository. Sebastian already mentioned this. A great example for this kind of repository is Zenodo. You can store all kinds of information on there, all kinds of data from all disciplines. A second one is a discipline-specific repository. This one is linked to a specific research field. We always recommend our researchers to choose a discipline-specific repository because the surrounding information, the documentation, the metadata standards that you have to provide for your data is more specific to your research field. That's why we recommend this one, this kind of repository. Then you also have a national repository, which is linked to a different country, a specific country. You have an institutional repository, a project-specific repository, and lastly, a journal-specific repository. This one doesn't occur very often because most journals just give you a list of the repositories they recommend or they think are trustworthy. So you won't find this one very often. Then why should you make use of a data repository? It facilitates data sharing and reuse. The verification of research results is easier. It avoids unnecessary data collection and or creation of it. You have the possibility to integrate several data sets, for instance, for a longevity study, or it's a great way to valorize your research output. It makes sure your data doesn't get lost, and it is more and more required by funders and publishers. So it's just, well, a good idea to make use of these data repositories. It's good scientific practice, as it says on the slide. Then if you use a research data repository, this will help your scientific reputation. The compliance to the data management requirements gives you more credibility, especially if you have publicly funded research. You kind of give back to the taxpayers, because it's funded by them. So your data is considered as a public good in a way. So that helps build your reputation. On the other hand, you get more citations. It is proven that if you make use of data repositories, then you will gain more visibility and you have greater impact. On top of that, it helps with funding because data is more and more viewed by funders as a research output. So it can be used in applications for funding also. So it just gives you another level on on your research outputs, and you get rewarded for it too. I mentioned this before. You can put all your data in a repository. Some data you shouldn't make available for the general public. For instance, personal information which will lead to identification of your subjects, or other sensitive information like religion, sexual orientation. Those you can't just throw in the general public. Then also data that is meant for dual use. This means that it has civilian and military applications, and there's also data that you can valorize that you shouldn't put in a repository. So you should be careful with using the repository. Always contact your facilities in your institution, your DPO, your data stewards, and they will help you with information on what you should publish and what not. Then also here, FAIR is mentioned before by Sebastian. The role of FAIR in choosing a repository is, it's a big role, because the data in the repository, it should adhere to these principles. Sebastian saw these principles before, so I'm just gonna skip over this a little bit. You have, again, the findability, the accessibility, interoperability, and the reusability here. We'll see how this is important for your data repository. How can the data in a repository be findable? Again, Sebastian mentioned this also, it should assign a globally unique and persistent identifier, for instance, a DOI, and this will make sure that your information is linked through different information platforms, and it is always findable. Then it should also be the information in your data repository should always be indexed in different catalogs and services. For instance, like DataSite, OpenAir, and other platforms like that. It gives you you should only have to upload it once, and then it's through these catalogs it can be found, well, everywhere if you look for it. Then what level of accessibility should a repository provide? This is also very important because a repository should be open access by default. This means that the data in the repository should be freely shared with anyone. As I mentioned before, not all data can be freely shared with anyone. That's where the access restrictions come in. You can share data in a restricted access. This means that if certain conditions are met, then you can share the data. This is, for instance, for the well, more delicate information like person-related information. Then you also have the closed access. This means that it cannot be shared under no circumstances. And then you have an embargo. This means that you can freely share your data after an embargo period, during which the data is inaccessible. So this is, for instance, when you your data is can be valorized or something. So yeah, if these access conditions are available, well, if you well, yes, the access conditions, if they apply, then you have to put it in the data use agreement, of course. This is also important for the reusability. Then interoperability also, you have to make your data interoperable. There's you have to also use the persistent identifiers that I mentioned before. Also here, the metadata standards that Sebastian explained before. Well, they give you the common components of metadata that give you a description, the context of your data. It will give you extra information. Also on Thursday, there will be more information on this. Then another way to make data in a repository interoperable is by using standardized formats, which Sebastian also explained, so I'm not going to go further into this. And then a clear access strategy is also a way for a repository to be interoperable. What will happen when your data repository ceases to exist? Do they have a way to extract the information, the data that is inside, or, well, these kinds of things? Then lastly, the reusability of your data is also important. The terms of reuse have to be determined. That's the least thing that has to happen. These include like attribution, copyright requirements, and if there is control on the commercial exploitation of your data. If there are severe restrictions on this, this also has to be added to your data use agreement. Then also here again, the reuse license, it should make instantly clear under what conditions you can use the data. Then Creative Commons is the most common type, like Sebastian explained, and well, most used of these types is CC BY and CC 0. Then it is important to well, look into which repositories you can trust. Sebastian also reused this cartoon, which is a very nice cartoon, because a trustworthy repository should not be a data swamp. It should be compliant with the fair data principles that I mentioned before. It should be compliant with the metadata standards. It should be linked to the data creator via the ORCID ID, which is also a persistent identifier. It should be discoverable through data catalogs or metadata catalogs. It should include access and reuse information like licenses, and it should be certified. But the certification I will talk about later on in this presentation. I will just skim over a few of the selection criteria you can use to look into a good repository that fits your needs. For instance, one of the most important ones, again, is the persistent identifier. Then also the repository has to make use of metadata standards, and you should be able to provide metadata. Then also the data access and the usage licenses should be provided, and the repository should have, well, a few preservation strategies to ensure that the metadata and the data can persist for the long term. If you're looking for a repository to deposit your data, you should always check first with your institution, with your data steward, your DPO. When in doubt, we always recommend to our researchers to use a discipline-specific repository or an institutional one, if this is applicable, of course. But you should definitely go with a reputable repository. Again, do not share all your data, especially if you have personal data. What is the policy in your institution? Do you have an institutional repository? You should try to use that one if it's applicable. If not, is there another policy in your institution? You should always ask first within your institution, of course. And then ideally go certified. Certification, I mentioned before, is one of the most highest reputations a repository can get. There are three levels of reputation a repository can get. Firstly, you have listed a repository that is listed in a registry, like RE3 data that Sebastian already mentioned, or it is broadly recognized in a research domain. A second level is that it is endorsed by a relevant funder, a journal, or a professional society. And thirdly, you have, of course, the certification to an international standard. This is, as I said before, the highest reputation you can get. But you have to keep in mind with the certification that not all repositories are certified. For instance, Kartra Seal, which is one of the most famous certifications, it doesn't certify. Well, it only certifies domain-specific repositories and not general purpose one. That's why Zenodo isn't certified, although it's a very commonly used repository. But I think they will be doing it in the future, just not now, not yet. But well, so you have to keep in mind. You have to keep this in mind when you're selecting a repository. Don't only look at the certification. You should, well, if, for instance, a certain kind of repository is more used in your scientific field, well, think about that one too. Exercise your own discretion. Talk to your data stewards. Talk to your institution. They will help you with these questions, of course. And then how can you find a trustworthy repository? The most easiest way is make use of search engines. As I said before, the Registry of Research Data Repositories is the most famous one. Through this search engine, you can narrow down your search. You can use parameters to find a repository that suits your needs. And well, this is a very easy way to do this. Then another important part of the archival part of your data lifecycle is the appraisal of your data. Should you keep all your research data? That's a question you have to keep in mind at the beginning of your research, because, well, at the end of your research, you have to document and preserve everything you need to verify and or replicate your study or to reuse your data for other researchers. If you keep all your data, this will become very costly, of course, because you have to pay for, a lot of the times you have to pay for storage. So a way to cut in your costs is to appraise your data, what is necessary to keep to show the, well, let's say next generation of researchers how your research is done, and how well, and how they can replicate it or reuse it, what is needed for that. There are a few evaluation criteria you can use. For instance, there are a few policies. There's maybe you should, well, maybe there is some long-term value. There's a reuse purpose. Well, these evaluation criteria, by the way, they are more broadly informed upon in the data guides, the training guides I wrote together with my colleague that I mentioned in the beginning of the presentation. So there's a lot more information. It's, well, a few examples also. So always welcome to look the training guide up when it's published. Then some final remarks. Do yourself a favor and plan ahead. Make decisions to publish or share your data in the beginning of your research project. You can still reevaluate later on. This is also mentioned in your DMP. So you can write down in your DMP where you're going to store your research data. It's just important to keep all of this in mind when you start with your research project. Then if you have questions or feedback, again, I welcome you to look into the training guide we wrote. This is a lot more broad than this one. And if there are then still questions, you can always contact your own facilities at your institution, your data stewards, your DPO. You can also send a mail to dmp@vub.be or cava@vub.be if you want more specific information. Always welcome to send an email. Okay, that's about it, I think.
Yeah, thank you very much. That was also very very informative. I think it also picked up a lot of the things indeed that Sebastian already presented, and shows really how much it is interconnected to think about all these issues from the start on. And the first step is to be aware, and then to decide how to move forward. Now I see a very first question in the chat from a participant, and that is mainly about the funding of these repositories. First, how are repositories funded? And second, how do scientists sometimes have to pay to deposit the data? Julie, do you want to react to that maybe?
Well, the repositories, it depends what kind of depository it is, if I understand the question correctly. If it's an institutional repository, of course, the institution funds it. Sometimes it's a collaboration project of different countries. It's just, well, it depends. And do scientists have to pay for the repository data? That also depends on your institution. What is the policy in your institution? You should always talk to your institution first, because they know everything on this subject. Well, sometimes they do, sometimes they don't. It just depends.
And yeah, I see, Sebastian, you want to react to that.
Yeah, maybe I can also add at one point there. So particularly with the data uploads in different repositories or in different forms that are available, this can have all sorts of varieties that are of different use also later on, let's say during particular assessment practices, or for advancing you at different career stages. So for example, at University of Ljubljana, we still have an assessment system that's very highly counting these different kinds of publications. And so if I'm opting for a data journal instead of a repository, then of course there's additional contributions to my habilitation points and all these kind of things. So these are things to keep in mind. Then of course data journals, although doing essentially the same job as like a peer-reviewed repository, but they do cost, of course, publication fees. In return, some of the repositories, or many of them, actually do not in the way we currently set up. So it's really something to also consider local practices and your particular situation.
Yeah, thank you for the extra information. I think also in terms of the costs, many funders make it eligible these days to include the data management and also the storage costs to some extent in proposals. So this depends a little bit on the research funder, be it the university itself, or like an external, like a national funder or the European funding, for example. And then there's also a little bit of the question, of course, especially when it gets very, very large in terms of the volume. That's definitely, it's still nonetheless a challenge. So that's definitely, as Judy said, I think something to discuss with your institution, for example, or with a repository even directly in case it gets very big, because in some research areas, of course, you have terabytes of data, and then preserving that for decades is definitely, it does cost some money. Are there any other questions? We have planned some more 15 minutes here from the audience. I see somebody wants to put something in the chat, but you can also raise your hand if there are any other questions. There's now another question that I don't really understand, because how is SRA from the NCBI funded? In both cases, I don't know what it is, so I don't know if any of the speakers know these institutions or organizations. Seems we cannot answer the question.
I don't
very
know.
sorry about this.
So,
we don't know everything.
Not being familiar with the terms, I at least did a quick Google search. So apparently this is DNA related, a sequence read archive, so one specific repository. Yeah, being from a different field, I don't have an overview how that is financed. I mean, there's so many different repositories that I think it's hard to keep track of all fields.
Yeah.
I mean, Julie, is this also part of the certification of repositories to show how they are funded? Is this possible, or is this? Am I on the wrong track
not
here?
really sure. All the specifications of the certification. I can maybe look up very quickly.
In any
Well,
case,
there
I
are,
think, yeah.
Yeah, no, there are a lot of certifications, but you can look it up if you go to, for instance, like the CortraSeal webpage. You can see everything they request from the data repositories to be certified. There's a whole list. I don't know everything by heart. So yeah, the website maybe I can.
Yes, I added it to the chat.
Oh, okay.
Yeah. Because yeah, I think in some cases some certifications do ask for a little bit about the governance or the funding mechanisms behind it. But I don't know if that has to be public, but this might also be incorrect. So please, for the people who have these questions, please check this also yourself. But many repositories would at least say if they're affiliated to an institution, and if there is a question, you can also usually contact them. I think this is also part of a certification, though, that they should be reacting to your emails, if I'm not mistaken. Are there any more questions here from the audience, or also fill the next few minutes by saying that we answered every question very clearly. So this is a very good thing. I think, Julie, you also said, indeed, I did not mention this in the beginning, that the slides that you prepared particular, but also some extra information will be part of our, let's say, training guide on data repositories, where this is all made available with a few more details, right? So this will be coming in the next few weeks, I think, before the end of the year.
It should be published in November somewhere.
November. Good. So ready for December and Christmas.
Yeah.
So that is perfect. I think I wanted to ask just Sebastian also because you're also a researcher and you're obviously very knowledgeable. How was the learning curve for you as a researcher to engage with these things? Because I'm sure you have not started from day one with all being aware of these open science practices, right? Maybe this is interesting for others who see a big wall of information in front of themselves and don't know where to start.
So I would say steep. So yeah, indeed, of course, this came in several steps, I would say, but usually always with particular purpose or with a particular occasion. So having one European funded project, I was required to draft my data management plan. So this is when I started to look into data management plans and figure out, hey, look, that's something really useful. That's something that I'm going to keep doing. Similarly with the repositories, I needed by that time, or rather I opted in with open data because I was eager about this, understanding how much this would have eased my own part in earlier years. And so then when I also had the possibility to opt in, I said, yeah, great, I do want to do this. And then, of course, there was a steep learning curve. How do I go about this and collecting all this information? So it's really purpose-driven, I would say, in few large steps, and then how to go about this and how not to be just drowning in all these different kinds of information. That's in part how I try to structure my presentation to show, look, that many of the things you are already doing, many of the practices are already somehow hidden down there, and it's just worthwhile to think explicitly about them. And some other things, there's really very good training materials. And so this is why I put then also the links at the end of my presentation. These are few selections that I found very, very worthwhile. And so these are absolutely the ones I would recommend.
Yeah, thank you. And seeing that I don't see any more questions, and I think this would be some perfect closing words, actually. So if there's nobody else who types or raises his or her hand, then I would say we can close here today. I just put also for the ones who may be interested in the next events, the registration links also in the chat. We will share the presentations as well. Sebastian's is already available on Zenodo even, so this is an extra good practice, which is very nice. But yeah, we will keep you in the loop, the participants here, with the slides, and perhaps also about the training guides and where they are available before the end of the month. And with that, I would just say thank you, especially to the two presenters, Julie and Sebastian, for coming and taking the time today and preparing everything. And I hope it was very insightful and useful for our participants. So thank you very much. And then I would stop recording here and then close the session after that. Thank you.